I'm Anil Kumar. Welcome to my mathematics series with Amy. Amy is a bright student from London, UK. We have an excellent strategy to understand the concepts and bring them to you. What we are really doing is first getting into the details of every topic and then selecting the best questions which have appeared in past test papers.
Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm all good, thank you. How are you?
Very good. Amy, I like the selection of questions which you make for our class. And it seems that you're really working hard. And wherever you get stuck,
Mm.
there, I think many students will get stuck. And therefore, it is like very useful for students to understand what kind of difficult questions could be there in the test paper and how do we solve them.
Definitely. Because I feel like the ones that I can obviously do are like, when the school teaches you like the formula or something, you can just work through it and the question is exactly the replica of what you do in class. But then there are some certain questions that I do with you that we don't do at school. So that's why you stumble upon that like as an obstacle. So if we get like better at doing those kind of questions, then we'd obviously score better and it would just be easier overall.
Perfect. So, what do you have for today?
So yeah, again, actually today's lesson is kind of be focused on like exponentials and logs.
Okay.
So the standard exponential and log questions I can do, it's just now these little bit tricky ones, a bit more wordier. These exponential and log questions are really wordy. So yeah, hopefully.
So why not
Okay.
share? Let's see.
Okay. So actually, let's go in order. 7. So I had an issue with 7B. Yeah, 7B.
Let's read
And
the
then
question.
C was okay. Okay. So water is being heated in an electrical kettle. The temperature is theta degrees Celsius of the water, and T seconds after the kettle is switched on, it is modeled by the equation theta equals 120 minus 100 e to the power of minus
lambda t.
Okay, I didn't know how to say that notation, where t is in between 0 and t, both included. So part A, state the value of theta when t is 0.
Correct. So that's simple. So we can just substitute 0 there. So once we do that, t equals to
20.
0. Yes. So we get theta equals to 120 minus 100 times e to the power of 0, right? So anything to the power of 0 is 1. So it is 120 minus 100, 20 degrees. So that is the answer for part A, correct?
Yeah.
Second part.
So given that the temperature of the water in the kettle is 70 degrees Celsius when T is 40, part B, find the exact value of
lambda.
Sorry, what did you say?
Lambda.
Lambda. I feel like you've used that notation. I know alpha a lot.
Alpha, beta, lambda, gamma, theta, in that sequence, lambda also.
Oh, right. Okay. So lambda, giving your answer in the form ln a over b, where a and b are integers.
Correct. We have this equation, which we have theta equals to 120 minus 100 k e to the power of minus lambda t, right? Now we are given that theta is 70 and t is 40. So we'll just substitute this value. So 70 equals to 120 minus 100 e to the power of minus lambda times 40. So bringing this here, get 100 e to the power of minus 40 lambda equals to 120 minus 70, which is 50, correct?
Yeah.
So we could write this as e to the power of minus 40 lambda equals to 50 over 100, which is half, correct? I can take log both sides, natural log. So I get minus 40 lambda equals to ln half. Is that clear?
Mhm.
So we got lambda equals to minus 1 over 40 ln half. Till now, there is no problem, correct?
No problem.
Now let's see like this. We have lambda equals to minus 1 over 40 ln of half. So I can take this minus as an exponent. So I can say 1 over 40 ln half to the power of minus 1.
Oh, yeah. Because that's the same as writing like
Yeah.
minus ln of half.
So now this, right?
Okay. Yeah. Got it.
Is that clear now?
But when I wrote my answer, so when we like, the answer of ln half over minus 40,
Yeah.
why is that not in the same form that they're asking? Is
They
minus
don't want,
40 not
yeah,
in-
they don't want those negative and they want you to simplify as this, right? Where, yeah, I mean,
Oh, okay.
yeah, both are integers, right? They don't want half as one of your answers.
Oh, yeah.
When they
half.
say integers, they do not
Oh,
want half as one of the answers.
Okay.
I think that is the reason. It's pretty good. I think it's a good point. You asked this question. It should help many students.
Definitely. Okay. Yeah. So I think I'll just lose the 1 mark out of the 4 for that last part.
Yes.
So it's good to get that. Okay. So that question makes sense. Thanks, sir. And then, yeah. So 9.
Mhm.
So again, I didn't do part A and B, but
Mhm.
I did get part 2, which was II, that 4 marks.
Okay.
So yeah, I'm
Good job.
following
So-
your method.
Strategy, you love that strategy, right?
Yeah, I do.
If you don't know part A or B, you should do
Just-
part C and D, right? Whatever
Yeah.
you can do, correct?
Yeah,
No
that's
problem. That's a good thing. So let's do part A and B now. Can you please read the question?
Yeah. So all the terms of a geometric series are positive. So the sum of the first 2 terms is 34, and the sum to infinity is 162.
Perfect.
So
Geometric
find-
series, A and AR, right?
yeah,
This is right. Now it says sum of first 2 terms is 34. That means A plus AR equals to 34.
34.
And the sum to infinity is 162. So what is the formula for infinity?
A over 1 minus R.
1 minus R. So sum to infinity is 162 and A over 1 minus R. So you get 2 equations. Now please read the question.
You're just going to
Find
sub in
common.
that one into that. I understand, but I don't know. I must have made a silly mistake because that is the approach I was trying to get to.
Perfect.
So
So
yeah,
let's look into
you
the
have to
first
find the
equation.
common ratio.
Yeah, let's look into the first equation. See, you can take A common, right? So you get 1 plus R equals to 34, correct? So, and second equation is 162 is A over 1 minus R, correct? So you can substitute the value of A from any one of these equations into the other equation. Perfect. You can do that.
Right. Yeah.
So, for example, here, this can lead to what? This can lead to A equals to
34 minus AR.
162 times 1 minus R. Correct? I could write this equation as A
Oh,
equals
yeah.
to cross multiply. Is it okay? So on
Yeah.
left side, I have A and all this, correct? I can substitute this here and simplify. Like what I know what this. So let me call this as equation 3 and this as equation 4. So I'll sub 4 in 3. I could also divide one equation by other and get rid of A. And I substitute A value 162 in that. So when I sub, I get 162 times 1 minus R times 1 plus R equals to 34.
Oh, yeah.
Now, 1 minus R times 1 plus R is 1 minus R square. Is it okay?
1, yeah. Difference of 2 squares, kind of.
Yeah. Some Product of sum and difference is difference of squares.
Yeah.
So at this stage, you can divide or you can subtract. Either way, you could do it. Let's multiply. Or we say 1 minus, or let's say 162. This is simpler. 162 minus 162 r square is 34. So 162 minus 34 is 162 r square, correct? So how much is this? 162 minus 34?
128.
128 equals to 162 r square. So r square will be 128 divided by 162 r square. So I can do the square root of this.
Which is 8/9.
8 over. So r value is 8/9. Is that clear to you? So we got r as common ratio as 8/9. We can now find the value of a. A is equal to 162 times 1 minus 8/9. Calculate this. 1/9.
18.
Divide by 9. 18.
18. Yeah.
18. So A is 8. So that is how you get the answer for part A. Is that clear to you?
Oh, yeah. Yeah. I feel like your approach was just so much easier. I don't know, because questions like this, when there are multiple ways of going about it. Like you said, like I could have subbed that into that, I could have done that and that.
I could divide also, right? I avoided.
Your way is just easier.
Yeah, I avoid fractions.
Oh, where possible. Okay. Yeah, because I found it quite hard to divide over, and then I must have made a mistake. Okay.
So I made fractions only at the end, finding r squared, dividing, and then doing square root, taking help of calculator. Right. Rather than putting it right there, I could have divided and got rid of a's, right? And calculated, but then we had some fractions involved, and that is where I think students get stuck.
Oh, okay. So when you can avoid fractions.
Avoid fractions. That will help you.
Okay. So I'll keep that one in mind, especially when there's so many other ways of going about it.
That is.
Like this question.
Sure.
Okay. So it makes sense. That was that. Yeah, so now this is the kind of where the tricky stuff happened. 10 and 11.
Okay.
Okay, so the value of Bob's car can be calculated from the formula V equals 17,000 e to the power of minus 0.25t plus 2,000 e to the power of minus 0.5t plus 500, where V is the value of the car in pounds and t is the age in years. Perfect. So part A, find the value of the car when t is 0.
So when you substitute 0 here, so we get 1. Yeah. So value of the car when t is 0 is, substitute 0, that part will be 0, power will
17,000 plus 2,000 plus 500.
Yeah, how much?
Which is 19,500. I just calculated that.
Perfect. So this is what you get in pounds.
Yeah.
Okay. Calculate the exact value of t when V is 9,500. So substitute 9,500 here. I'll need space also. So we'll do V equals to 17,000 e to the power of minus 0.25t plus 2,000 e to the power of minus 0.5t plus 500, correct?
Yeah.
When you substitute 9,500 equals to 17,000 e to the power of minus. Let me write this as a fraction. It'd be better for you to look at quarter. Do you see?
Okay.
Plus 2,000 e to the power of minus half t plus 500, correct? So we have substituted the values given to us as 9,500. Now bringing this here, we get 9,000 equals to 17,000 e to the power of minus 1 over 40, that is the quarter, plus 2,000 e to the power of minus half t. Now dividing by 1,000, we get 9 equals to 17 e to the power of minus quarter t plus 2 e to the power of minus half t. So this is the place where we kind of stuck. Think like this. We are looking at two terms, which is minus quarter and minus half. Is it okay?
Yeah.
So now, or you can say minus 2.5.
Oh, sorry.
Yeah, e to the power of so quadratic. This is square of that, but with a negative term.
Mhm.
Negative u. So if I substitute e to the power of 2t, so if I substitute u as not right u, let's say p as equals to minus half minus 1 over 4, then 2p will be equals to minus half. Is that clear? If I write p as minus 1 over 4,
Yeah.
2 times p will be minus half. Is that clear?
Right. Yeah.
Now think like this, okay? So we are making this substitution. So I think that will make things 17. So e to the power of minus 1 over 4, I am writing as p. Is it okay?
Yeah, so let p equal minus a quarter t.
Yeah, is 2p.
Okay.
Correct? So it is like, now I'm saying this, that e to the power of p, let this be equals to q.
Okay.
Slightly tricky, just bear with me. So
Yeah.
19q plus 2q squared. Do you see that?
Oh.
So it is 2p. So it becomes q squared.
Right, right.
Now it is a quadratic equation. So I could now write this as, so let's space here.
2q squared plus
Okay.
17q minus 9.
Plus 17q minus 9 equals to 0. So
Yeah.
18, and we want that 18 to be as 18 minus 1 will give us this, right?
Yeah.
I could write this as 2, let me write now in writing, 2q square plus 18q, okay, minus q, right?
Mhm.
Minus 9 equals to 0. Perfect. So I can take 2q common and factor this. So q plus 9 minus, I have q plus 9. Is it okay?
9
Now,
minus
q plus 9 is common. So I get 2q minus
1
equals to 0. So
Yeah.
that means 2q equals to 1, correct? Or q is minus 9, but q is positive, right? Where q
So
will be
q is a
always
half.
greater than 0, right? So q
Mhm.
is half, right?
Yeah, so it can't be minus.
Can't be minus.
So, right. Okay.
Now you have to get back and get the solution. I think
Yeah.
by breaking it down like this, so e to the power of p is q, right? So e to
Yeah.
the power of p is half. That means, is it okay?
And we said p was minus a quarter t, so we just sub that back in.
Okay, so we'll do it in small steps. We'll take ln
Yeah.
now. Ln means p equals to ln half. Is it okay?
Yeah.
And what is p equals to? P is minus
So
1 over
minus
4.
a quarter t.
Oh, yeah, t was here. Yeah, quarter t, correct. So p is minus of quarter t. Is ln half. Is that clear to you?
Yeah.
So that means t is equals to 4 when you take it on that side, and minus will make it 4 ln half to the power of, so it becomes ln 2. Do you get the idea? As we did in last example.
Oh, the same principle, right?
Same principle. Do you understand?
Yeah,
so
yeah.
t equals to 4 ln 2. So that is how we can get our answer. You get the idea?
Oh. No, so yeah, that was, at least I know how to approach it next time, but that was a tricky question.
It is very
Only
difficult.
4 marks. That looks like it should be 8 or 6.
Yeah, I think I'll try to find a simpler solution, but this is like kind of straightforward. We did do
Oh, no, no,
two
no. This is definitely straightforward.
substitutions.
Yeah,
Yeah,
yeah.
I have very limited space to work with them, so I cannot really have the luxury of doing it in a very orderly fashion.
No, that's all right. This was super clear. I think this is the like easiest way to approach it. Like
Okay.
I was looking at different ways of solving, and they were really confusing me. Like they did the quadratic equation, but they were subbing it with e in the equation.
Yeah,
And
that is
so,
difficult. You don't do
so
that.
hard.
Don't do that.
Yeah,
No, no,
it
no.
was really hard. That's why I'm saying yours is the best
Correct.
way. Mm.
So what I noticed really is that when we're talking about decimals, see, fractions I prefer actually. So
Yeah.
decimals 0.25 and 0.5 relates half to quarter, correct?
Yeah,
Half to quarter means one term is twice the other. Now exponent is twice the other means I can write it as a quadratic equation. And
right.
quadratic equation can be easily solved by
Yeah,
factoring or by the formula.
Yeah, that's
So
yeah,
that
really
is the
important.
approach. So we came down to a quadratic equation by a couple of substitutions. That's the whole idea.
Right. Yeah,
But
it's
I'll-
on. Yeah, either making EP as Q and then making P as something as well. So it's just 2 substitutions we did, and that was really nice. Okay. Yeah.
Great. Good question. Next question is?
Yeah, so part C of that then. Find the rate at which the value of the car is decreasing at the instant when T is 8. So give your answer in pounds per year to the nearest pound.
Okay, so that means you need to find derivative, right? dv dt, right? So v prime, dv dt is, so just find the derivative, minus 0.25 times 17, multiply all this, right? 17,000 e to the power of minus 0.25t. This is first part, plus. So that becomes negative because you're multiplying by negative 0.5, 2000 e to the power of minus 0.5t. Is it okay? And that is 0. Now here substitute t equals to what? 8.
8, yeah.
So see, just see, quarter of an 8. Do you see that? Quarter of an 8 is 2, right?
Oh,
And
yeah.
half of 8 is to the power of 4, correct?
4.
So that negative, of course, negative 2, but you kind of understand square root, right? Fourth root. You get my point?
Yeah, yeah, yeah.
So you use that substitution and calculate the value. It should not be difficult. You can multiply and do. So calculate the value.
So yeah, that'll be straightforward.
So that's clear. Okay, next question, please.
Okay, so question 11.
Mhm.
You know what I mean by wordy?
Yes,
Like an
really.
essay.
Correct.
Yeah, very. That's what kind of scares me. I avoid these questions because there's too many words and I'm doing maths. So I want to see more numbers. Okay. The amount of an antibiotic in the bloodstream from a given dose is modeled by the formula X equals D times E to the power of minus 0.2T, where X is the amount of the antibiotic in the bloodstream in milligrams, D is the dose given in milligrams, and T is the time in hours after the antibiotic has been given. Okay. So a first dose of 15 milligrams of the antibiotic is given. Part A, use the model to find the amount of the antibiotic in the bloodstream 4 hours after the dose is given. Give your answer in milligrams to 3 decimal places.
So substitute the value. So you get X equals to, dose is 15 milligrams. So you get 15 and E to the power of minus 0.2 and time is given to you as after 4 hours. Plug in 4 here.
Yeah.
Minus.
So I got 6.740 to 3 decimal places.
Perfect. In milligrams.
Yeah, part B was the tricky. Okay. So a second dose of 15 milligrams is given 5 hours after the first dose has been given. Using the same model for the second dose, part B, show that the total amount of the antibiotic in the bloodstream 2 hours after the second dose is given is 13.754 milligrams to 3 decimal places.
Okay. So second dose is given. I thought I will sketch a diagram. So we found one value. which is at 4, right? So we found at 4 some value, correct?
Yeah.
Let's say this is 6.74, right? Is it clear? Starting dose was 15.
Right.
So that is the situation so far. Now part B says second dose of 15 milligrams, same, is given 5 hours later. So 5 hours later, let's say here, we give another dose of 15, correct?
So 5 hours later means 9.
Uh,
At 9 on the graph, right?
No. A second dose of 15 milligrams is given 5 hours after the first dose. That means if you start, 5 is here only, right? It is not related with 4 hours of the previous one. Okay.
Oh.
You might get that mistake. Okay.
Okay.
I get you.
I thought 4 was the first dose for some reason.
So yeah, I understand what you mean by wordy problems, right? You get lost. Like
Yeah, it's what I mean. The English. Wait. Okay, so
So again,
4
read it.
hours. Oh, so it's got nothing to do with part A. You know how usually part B and A are related?
Yeah,
Oh,
nothing
okay.
to do with part A. Yes, yes. Part B
Oh.
is independent. Yes. First dose was given 15
Yeah.
milligrams. That is important. Now part B, please read again.
Okay. Apparently I have to read it like 5 times. So a second dose of 15 milligrams is given 5 hours after the first dose has been given.
First dose, yes.
Which was 15. Okay.
Yes. Hmm.
So using the same model for the second dose, show that the total is that. Okay.
Okay. So now second dose is given and it will follow the same path, right? Then after how much is after?
After
So
2
total amount
hours.
of- after 2 hours. So 5 plus 2 is 7, right? So somewhere here, right? So do you understand the figure now?
Yes, yeah.
So basically, we are left with something of the first dose and something of the second dose. Think like
Right.
this. Keep them separate. So first dose, what is left? Second dose, what is left? And add them together.
Oh, okay.
It'll be very simple. So now we want at this point 7. So as far as the first dose is concerned, we have used 7 hours, right?
Yeah.
So that value of x remaining, let's call this as x1, is 15 e to the power of minus 0.2 times 7.
Times 7.
And x2 is 15 e to the power of minus 0.2 times 2. Do you get the idea?
Oh,
Add them up, so you get total x.
I see. Okay, let's do some maths. Minus, okay. So x1 is 3.6989. I'm just going to write like so many decimal places.
Okay, yeah.
And then,
4 decimal places you need, yes.
oh, okay. So e to the power of minus 0.4 times 15. So 10.0548. Add them.
Yeah, you'll get the same.
Yeah. 13.7537.
So you round to 4.
Yeah, so 754. Yeah.
Perfect. So you have to do 4 decimal places for each and then add. Do you understand this? How
To avoid any, rounding error. You want to keep the numbers long. Okay.
4 decimal. You want accurate to 3 decimal? Calculate for 4.
I'll just do one more.
And make a small diagram. It helps to understand the situation, correct? And we are like keeping them independent. That's the whole idea now. Next part, please.
Yeah, so my actually main issue was that number one, I didn't draw a diagram. Number two, it's so hard to see that they were independent without the diagram. I started combining them and made like 9 hours and then adding like everything else, getting really confused. Okay, so keep them independent. Okay, cool. And then no more doses of the antibiotic are given at T hours after the second dose is given. The total amount of the antibiotic in the bloodstream is 7.5 milligrams. So part C, show that T equals A ln times B plus B over E, where A and B are integers to be determined.
No fractions, right? So if I have minus, you have to flip it and write as an integer. No fractions, right? Remember that.
Yes.
So we have learned many things here. Very good exercise. Ami, I really appreciate the selection of your question. Brilliant, brilliant questions. Okay, now it says find T when the remaining dose was 7.5 milligrams. So this value of X is now 7.5. Is that okay?
Yeah.
From the first one, we have that T is at time T hours after the second dose. So after the second dose, we are at T hours, right? So let's say this is T hours, correct? So
Yeah.
from the first, it will be T plus 5. Is it okay? T plus 5
So,
from the first.
yeah.
We have to add. So in this equation, I have 15, 15, right? Which is common, correct?
Yeah.
Or you can write independently 15 e to the power of minus 0.2 times T plus 5. Because this was given 5 hours earlier.
Mhm.
And now it is 15 e to the power of minus 0.2 capital T. Is that okay? That is the total dose which will remain after T hours of the second. You get the idea now? So Amy, in part B, it is given to us that 7.5 milligram remains. So 7.5 is equal to, so in the first case, initial dose, it is there for T plus 5 hours and the other one is for 5 hours. So we get this statement. Is this statement clear?
Yeah. Wait, so where did the 5 come again? Oh, because
Second dose is
second
after 5 hours, right? And 3
Okay.
hours after the second dose.
Oh, so yeah, for the first dose, that would be the T plus 5, and then for the
Yeah,
second
yeah.
dose, it would just be the T.
Therefore, we have T plus 5, right? So now
Yeah,
let us divide, or just keep this as such. We can divide every term by 15, right?
Mhm.
Well, let's divide by 7.5. Is that okay? So we
Yeah.
get 1 equals to 2 e to the power of minus 0.2. Let me open this up. T. And then when it is plus, it is like a product, right? Product e to the power of. When you multiply this, minus, it becomes minus 1. Is it okay?
Mhm.
Plus, this is 2 e to the power of minus 0.2 t. Is this clear to you? So just open the bracket.
Yep.
Now, what can you take common? You can take common e to the power of minus 2 times
0.2
e to
T.
the power of minus 0.2 t. You can take common, correct? We get e to the power of minus 1 plus 1. Is that clear to you?
Yeah.
Now, this part is a constant, and that is a variable, which is e to the power of minus half t is variable, correct? And that is a constant. So we bring it here, we get e to the power of, because it is minus, it becomes plus here, right? 0.2 t equals to 2 times minus power means 1 over e plus 1. Is this okay?
Mhm.
Perfect. So now let me take it to the center place to solve. I have really less space to work with. Let me take a darker color. Okay, here, there you go. So we have e to the power of 0.2 capital T equals to. Now, if you look at the equation, we have b plus b over e, right? So let me
Yeah.
take 2 inside, multiply them all, right? So we get 2 over e plus 2. So I have kind of matched this. B
I
plus
see.
b over e, right?
Yeah.
Now I'll take ln both sides. So if I take ln, I get 0.2 t equals to ln. Here we have 2 plus 2 over e. Is it okay? So we have b plus b. I know value of b is not 2, right? Kind of like this. So
Yeah.
now t is equals to 1 over 0.2 ln 2 plus 2 over e. So 1 over 0.2 is how much? 10, right? 10.
Yeah.
So you can multiply by 10. So get 10 over 2, which is
5.
So which is 5. So get 5 times ln 2 plus 2 over e. Is it okay? when you compare A equals to 5 and B equals to 2, does make sense?
Yes, but I don't know where I lost you. I thought when we did it, we got 7.5 equals 15e
Yeah, yeah.
minus 0.2 t plus 5.
Yeah. Then I divided by
50.
7.5 because I don't want that 7.5 decimal. I divided 15 divided by 7.5 is 2, right?
So how come you didn't want to divide everything by 15?
Because I will get half. I want to avoid that half. I could do that.
Oh, okay.
So instead, I prefer
Okay.
to put 2 there, right?
Yeah. So you just want to avoid fractions again.
Again, yeah, fractions of it. Yeah, that's it. So I took
see.
2e and then I took it common and then solved it, as you can see, right?
That makes sense.
So that is how we could actually solve this particular question.
Right.
So,
That's clear.
any other questions?
I do have 2 more, but I don't know if we have time.
Okay, 2 more. So anyway.
No more exponentials and logs though.
Okay.
They were more sequences based.
Perfect. So let's close the class here. In the next class, we'll take all other questions which you have. But today was a great collection of questions, all based on exponential and logarithmic functions, and a lot of stuff here. Good.
A lot of stuff.
Amy, did you learn something from today's lesson?
So much that my brain is finding it hard to grasp everything. But it's a good thing that you made a video, so I can always rewatch everything that's been learned. But yeah, so we kind of like we touched upon a lot of things from graphing exponentials and logs, just making it a bit more clearer. Because I've noticed, especially with my exam board and the way that these type, especially the exponentials and log questions, there's a lot of words related to it. So yeah, depicting that out and making little graphs or images on the side, it just really helps put together what they're trying to say. And like we saw, with the 2 equations that we had, trying to keep the first dose and second dose as independent events made it really helpful instead of combining them. So yeah, it made it easier to get through the questions. And then other things from simple things like leaving your answer in terms of integers. So yeah, that further simplification of the answer, which I didn't manage to get, but now I understand we don't want to have any of the integers like fractions or anything. And wherever you can, if there's multiple ways of getting to things, like when we substituted like e to the power of p equals q, substituting that q in instead of all the e and p and everything, it's so much easier to maybe like solve a quadratic equation or like follow through with the answer. So things like that is really important. And if there are multiple ways of getting about to an answer, always choose the route that it has no fractions in it, and yeah, just to avoid any like error. Okay. So yeah, there were so many helpful things. So thank you so much.
Yes. And actually, I also learned many things from your question. One of them was that whenever it is written integer value in the question, very clear, you cannot write fractions. Yeah. Avoid fractions from the question itself, integer values. So there were opportunities, as you said, we could have divided it 7.5 by 15 and got half there, but avoid, because we want to get a whole number.
So if your answer is in integer value, make your working out also in terms of the integer value.
Right. And therefore, even while solving the earlier problem where we wanted to find a and b value, I could have divided that geometric series question. A and A could have got cancelled. But I think we had a fraction kind of a thing, right? So I prefer the substitution method over that, so that you work with the linear equation all through.
Right. Okay. Yeah, that makes sense. And it's so much easier to deal with anyway. And it's more like easier, more pleasant for the eyes. Because you know, when you go back and you're trying to look at answers, seeing fractions and refractions can be really like complicated. But if you see it nicely laid out without fractions, it's nice and clear. So yeah. Thank you, sir, for your help.
My pleasure. Thanks a lot for sharing, and keep sharing.
Okay, yes, we'll do, sir. Thank you. Bye.